Hey, this is Dexter. A stone with an initial temperature of 220 degrees Celsius was dropped into the water. As the stone cools, t minutes later, its temperature is equal to P plus 190 e to the power negative kt, where both P and K are constants. In part 1, show that P is 30. In part 2, given that 4 seconds later, the temperature of the stone is 120 degrees Celsius, find the value of K. In the final part, sketch the graph of temperature against time. This question is taken from Anderson Preliminary Examination 2021 for additional math. Pause to give it a try, and when you're ready, keep watching. The stone starts off with an initial temperature of 220 degrees Celsius. So, by replacing t minutes to be 0 and setting the temperature to be 220 degrees Celsius, we will form the equation of 220 equal to P plus 190 e to the power of 0k. Based on the zero exponent rule, e to the power of 0k is equal to 1. Solving for P will give us the answer of 30. In part 2, given that 4 seconds later, the temperature is 120 degrees Celsius. Notice that the variable quantity t is in minutes, so we will need to convert 4 seconds into 4 over 60 minutes. And replacing the temperature to be 120 degrees Celsius, we will form this exponential equation. Taking the 120, subtract it by 30, and dividing it by 190, we will have the constant of 9 over 19 on the left and e to the power negative k over 15 on the right. Let's bring in the formula for converting exponential form to logarithmic form. Given an exponential equation to be y equals to a to the power of x, its logarithmic form will be x equals to log y to the base of a. We will now start the conversion process with the base of a, and in our case, the base of e, and we will write log to the base of e, the mathematical constant, in our next step. Next, the exponent x is now the opposite end of the logarithmic equation. So, for exponent negative k over 15, we will now write it on the other end of the equation. We will now complete the conversion process by filling in the y, in this case 9 over 19, to be together with the logarithm. The logarithm, with the mathematical constant e as the base, is also known as ln. Solving for k will give us the answer of 11.2 seconds in 3 significant figures. For the last part, we are required to sketch the graph of temperature against time. Our vertical axis will be temperature in degrees Celsius and horizontal axis will be time in minutes. For any exponential graphs, there will be a horizontal asymptote, which is just a constant term in the equation, and in this case, the horizontal asymptote is 30. There are 4 graphs of exponential functions, with the 2 above the asymptote being positive exponential graphs and the 2 below are the negative ones. All exponential graphs have a common property, that is, their tail ends will always approach the horizontal asymptote but not meeting it. With the initial temperature of 220 degrees Celsius and the stone is cooling, it implies that the graph is a decreasing function. We will then be able to eliminate the 3 other graphs. And here it is, the required graph of temperature against time. Let's try a similar question. A slice of bread is toasted to 154 degrees Celsius. It is left to cool and the temperature is given to be 26 plus ae to the power negative kt, where both a and k are constants and t is the time in minutes after removal from the oven. In the first part, find the value of constant a. In the next part, what does the value 26 represent? The question continues by giving us the temperature of the bread to be 116 degrees Celsius after 2 minutes. In part 3, find the value of the constant k. the recommended temperature to consume the bread is at 45 degrees Celsius. Lastly, determine the waiting time before consuming the toasted bread. This question is taken from Anglican High Preliminary Examination 2021 for O-Level Additional Math. Pause to give it a try, and when you're ready, keep watching to learn how to solve this problem. By setting the time to be 0, the initial temperature is 154. Replacing it into the given equation, we will get 154 equal to 26 plus ae to the power of 0k. Based on the zero exponent rule again, e to the power of 0k is 1. Solving for a will give the answer to be 128. Moving on to part 2, the constant term of 26 is the asymptote where the tail ends of all exponential graphs will be approaching, as mentioned earlier. Since the bread is left to cool, this is yet another decreasing function graph, so as time increases, the temperature of the bread will approach 26 degrees Celsius. And logically, the value 26 should represent the room temperature. In part 3, given that the temperature of the bread is 116 degrees Celsius after 2 minutes, we will now replace both the temperature and the time into this equation. Taking 116, subtract it by 26 and dividing it by 128, we will get 45 over 64 on the left and e to the power of negative 2k on the right of this equation. Once again, applying the conversion of exponential form to logarithmic form, we can start off by writing the base to be e in our logarithmic equation. The exponent of negative 2k is now the other end of this equation. And let's complete the conversion by filling in the y, which in this case is 45 over 64, to be together with this logarithm. The logarithm with the mathematical constant e as a base is also known as ln. Evaluating for k will give the result of 0.176 in 3 significant figures. In the final part of this video, we will now replace the temperature to be 45 degrees Celsius and we are required to solve for the time. By simple manipulation of the constant, we should get 19 over 128 on the left side of this equation. Once again, bring in the conversion of exponential form to logarithmic form. We will then begin by writing the logarithmic base to be the mathematical constant e. The exponent in the previous step can now be written in the opposite end of the logarithmic equation. And once again, we will complete this equation by writing y, in this case 19 over 128, to be together with this logarithm. Just like the previous two conversions, we can rewrite this logarithm with the mathematical constant e to be a ln. And solving for this equation will give us the answer of t to be 10.8 minutes in 3 significant figures. And that's the answer for this question. Did you manage to get it right? I hope you have learned something today. Thanks for watching and see you in the next episode of Practical Math.